Hello friends, this is Rahul and this is my first ever YouTube video series. If you like this video series, do add a comment in the comment section. It will motivate me to make more technical videos like this. In this video series, I'm going to talk about a practical approach towards understanding uh, networking components like DHCP, DNS, ARP, and NAT. All you need is a laptop connected to a wireless router and Wireshark tool installed. Wireshark tool is a network protocol analyzer tool which helps in decoding network packets. You can download the tool from this link. It's freely available for both Windows and Mac. So let's get started. DHCP. Uh, you guys must have seen this environment wherein your laptop or mobile device is wirelessly connected to a Wi-Fi router, and from Wi-Fi router you reach internet, right? Let's call this environment as home networking. So where is DHCP used? When you connect to the wireless router, uh, the client laptop receives an IP address from the wireless router. And how does the wireless router assigns an IP address? Is via a DHCP protocol. So DHCP protocol is essentially the client makes a DHCP request for an IP address and the server replies back with an IP address. At high level, you can think of this. Now, what are the basic stuff you need to set up on your wireless router, which typically happens by default, but I want to cover it here. So you would need a DHCP pool. This is the pool or range of IP address the client machine will get an IP from. Okay. And there are a few other settings which I'll show you in a bit. And once the wireless router has assigned an IP address to your laptop, it caches that mapping. And what I mean by that is, let's say when the client made a request that it wants an IP address, it's going to send a request, right? So there is a field in that request which is the MAC address. So it caches the MAC address, and then if it has issued an IP address of 192.168.1.2 to that laptop, it'll create a mapping like this. And this mapping is valid till the lease expire. If a laptop makes a request again within the lease expiry time, it's going to get the same IP address. But if when the lease expire, this laptop may or may not receive the same IP address. So this is all this mapping is telling you. Okay. And on the client side, once you receive a DHCP response, it carries fields like IP address, which is the main use of this protocol. It also carries subnet mask. I hope you guys are familiar with subnet mask. If not, do let me know on the comment section. The default gateway, and then the DNS server. DNS server is something I'm going to cover in the next video. So enough of the theory. So let's see this in action a bit. Okay. So I have actually logged on to my wireless router. This is the IP address of my wireless router. And you would have probably have a different wireless router, but what I'm going to show here is um, this is the configuration I was talking about, that you typically find the DHCP configuration in the LAN section. You specify the range like 192 range or 172 range. These are like private IP addresses typically used for home networking. You specify the subnet mask, the lease expiry time, and the DNS setting, the primary and the secondary. And the mapping which I talked about was this is how the mapping looks like. So what it does is it typically caches the MAC address of your device, what IP address it has issued to, and how long is this IP address valid for. It says 23 hours, 6 minutes, and so on. So if I make a request within this time, I'm going to get the same IP address. But if I make a request after this time, there's no guarantee that I'm going to get the same IP address. Okay. So this is, you guys should actually log into your wireless router and like at least in a read-only mode, see what exactly is going on, right? So that is the whole intention, to show what exactly is happening. Now I'm going to take it to a next level wherein I'm going to actually show what exactly happens and how does it gets an IP address, right? So that is the whole idea behind this video. So what I'm going to do is you guys must be familiar with the network adapter. So this typically you find a network adapter on your host, right? Where on Mac, I have this network adapter which actually received an IP address. Your network adapter could be different. For Windows, this command is ipconfig, and you can look at your network adapter. So using this network adapter, you can actually communicate over the internet or on the network, right? So what I will do is I'm going to run TCP dump on my network interface. Okay, and TCP dump is a utility uh, which captures packets on a network interface. Okay, so I'm going to run this, and what I will do is it's running. What I'll do is I will disable my Wi-Fi. So when I disable my Wi-Fi, you will see that my network adapter, uh, it initially had the IP address 192.168.1.6, and now it doesn't have it, right? Now, when I enable this Wi-Fi, my laptop is going to make a DHCP request and it's going to automatically get an IP address. So now you see that it has received an IP address. And in the other window, I'm going to close it. So what this guy did is it recorded all the packet exchange which happened between your laptop and the wireless router. Now I'm going to show this packet capture in Wireshark utility. This is what I mentioned in this video earlier, that you should download this utility. It's a great utility to decode the packet. Now let's take a moment here before we open the decode. Okay, when you connected to the wireless router, the only thing you specified was the Wi-Fi name and then the password for Wi-Fi, right? How did you know to where to connect to get a DHCP server? Do you know the DHCP server IP address? Did you configure the DHCP server IP address anywhere? No, right? All you did was you just said connect to this particular SSID and this is the password, but you don't know where the DHCP server is running. So take a moment and think about, how did you even connect to a DHCP server, and how was the DHCP server able to assign an IP address to it? Things would be clear when I show you the decode, but uh, take a moment to pause the video and think over it a bit. Okay. Now let me open the PCAP file. It basically captures everything, but we would like to do a filter on DHCP. So this is how a DHCP request and a response looks like. So now I was asking you a few seconds earlier, how does the VA client laptop knows that this is a DHCP server it has to connect to? It doesn't know, right? So that's the reason what it does is, all it knows is its MAC address, which is this guy, and it doesn't know the destination. So at the L2 level, it sends a broadcast frame, which is with the MAC address of FFFFF. So typically in networking, if you send this frame, it is called a broadcast frame. And you also don't know the IP address of a DHCP server. You also don't know what is your client IP, what is the laptop's IP, because you are actually requesting for an IP address, right? So think about it. How would you know an IP address? So that's what you do, that you send a packet with 000 IP address and put this address as a broadcast, which is 255 to 55 and so on, and you construct or the basically when I say you, is the OS or the TCP IP stack which constructs this, and then you send it on a port, UDP port, which is 67, and this is where DCP server typically runs. And in the request, what you say is that you want to get an IP address, so you're making a DHCP message type request, and you are specifying your MAC address in the request. Okay, you are specifying your MAC address here. Now the DHCP server which is running on your wireless router, when it intercepts the packet or when it gets the packet, because it's a broadcast packet, it responds back like this. So you know that this is your DHCP server IP address. Okay, now if you see the difference here, you didn't know anything, so you send a broadcast, you don't know the IP address and so on. But in the response, you know that this is the MAC address of your router, this is the MAC address of your laptop, this is the IP address is going to assign to that particular laptop, right? So it's responding back with the DHCP response. And in the DHCP response, you are saying that your client IP is uh, 192.168.1.6. Okay. Uh, this is uh, the subnet mask which I talked about, that you pass in the subnet mask in the DHCP response. You pass the default gateway, which is this guy. You pass the DNS server, which is in this case this guy, or it can be 8888 or anything. So that's how typically you get an IP address. When you, just to summarize a little bit here, right? When you connect to a Wi-Fi router, you don't know anything. So you actually rely on DHCP request and a response protocol to get an IP address. So the client makes an ARP request on uh, and it sends a broadcast, and any DHCP server which is listening on 67 on your network will receive it. It's going to reply back with the DHCP IP and few other things like subnet mask, default gateway, and so on. And that's how you get an IP address. So I hope you find this video useful in understanding how essentially a client gets an IP address and what goes under the hood in a DHCP protocol. Next, I'm gonna talk about a DNS protocol. So see you there.